Hello everyone and welcome to yet another problem from Geeks for Geeks. This is one of the similar problem from the previous one, which says count pairs with given sum. It asks the given an array and an integer target, you have to find number of pairs in an array which sums up to given target. So for an example, let's take this array and a target 6. So with 1 and 5 we can get a 6. With 7 minus 1 we can get 1 6, and with 1 and the end 5 we can get another 6. So total 3 6 we have. Likewise, within second example, for target 2 we can get 6 as an output because there are 6 pairs. It is somewhat similar to the problem we have previously solved. If you wanted to know about that problem, click on the card above, which will be displayed. It is quite similar. Think for a while, how could we solve this problem with the number instead of a boolean output? Here we are given the array along with the target. So earlier we used to map the values to the particular boolean values. So if a value exists, then it's true, else not. Basically we were using just a set. But here we are going to use a mapping of value to count. So if I found 1 one time, so it will be 1 is occurring one time. So within this example, let me copy this like here. So 1 is occurring one time. Likewise, if I go ahead for 5 is also occurring one time, but with 5 can I get 1 because I wanted to meet a target as 6. So yes, so let me take count as 1 plus and iterating to next 7. Okay, I'll consider 7, but tell me if I have a minus 1. So that's not a case. So 7 doesn't contribute yet. Then we can go ahead. First let me jot it down. For this map is containing value to count. Okay, now we encountered minus 1. So for minus 1, do I have 7? Yes, we have 7, and this is only one occurrence, so let's take 1 plus. We will mark the entry of minus 1 is occurring one time. Now for 5, what do I want is 1. So how many times a 1 is occurring? One time, right? So I'll just go ahead and plus 1, and 5 we already encountered, so 5 is 1 plus 1, which is 2. Yes, in such a way we have populated the map, and our count at the end is 3, and hence we can return the count, and which is validated as well. You can test this with example 2 and subsequent example 3 as well. You will find that this solution works with them as well. So how are we going to go ahead? In this way we will be considering map of integer to integer, which is count to value to count. Now I'll be iterating one by one, and I'll be saying finding element. So finding element is equal to target minus I, where what finding element, how we define it is finding element plus I is equal to target. So making a formula for finding element is something like this, and I need to check whether finding element is already encountered. So map dot contains key finding element, and if this is true, then we got a pair. So if we got a pair, we need to go ahead and increment the count. So count plus equals to map dot get finding. And yeah, we also needed a count, right? So count is equal to 0. Let's make this final because we are not changing map. So map dot put, and I'll be marking the entry of I. So put I comma map dot get the current value of I, or 0. So I'll get a default 0, because it might happen that I is the first time entry. In that sense, we need to cater that. In the end, I'll return count. So let's submit this one and check how it works with the rest of test cases. So it seems that it has worked perfectly fine, and our solution has been submitted. This was under topic of hashing, and it is something similar to what we did earlier. So if you wanted to know more about that, click the video on your right, and I'll see you in the next one.